In this video, we're going to be covering curve fitting and how to do various regressions. Now, we're not going to be doing any particularly advanced regressions, and we're going to be using a graphing calculator to do all of these in this entire process for this video. So if you're looking for more advanced ways to do regressions, that's going to be in a separate video. Want to get that out of the way because there are more advanced regressions, and hopefully someone's not clicking on this expecting a high-level math video. Save them a little bit of time. But for what we are going to be doing, we're going to be using and working with scatter plots and then curve fitting based on that data. So starting off with what a scatter plot is just a graph where we put ordered pairs and plot those ordered pairs on that graph, but we do not connect them together like we've done in other videos discussed. What we are looking for is to look at the data points, the random dots that will show up on a graph, and say, based on the pattern of the points, does it look like this data is more linear in nature? It's got a straight line going up, it's going down, it's kind of maybe steep or it's kind of shallow, doesn't really matter, but it looks more linear in nature. Does it look quadratic in nature, more like our parabolas, kind of the upside down N, or a U, really. I guess it's a fancy upside down N. We've got a U, or an upside down U, which I guess that would be the N there. So quadratic in nature, or does it look exponential in nature? It starts off gradual, it starts growing, and then it just keeps growing and gets steeper and steeper and steeper. Or the reverse of that, it starts off fairly flat, it starts decreasing, and then it starts decreasing faster and faster and faster. So these are the three types of regressions we're going to be going through and covering in this video. For the sake of clarification for a student of mine, if you are watching this video, for my Math 72 students, we are only going to be worrying about linear regressions. For my Math 97 students, we are going to be using linear, quadratic, and exponential regressions. For the 72 folks, this is just going to be the one thing we're pressing, but the rest of the process to get to here is going to be the exact same as the other two, with a slight difference later on in our process here. So what we want to do, and I'll scroll this down here so we can get our overall process visible. There we go. I'd again recommend pausing the video, as I recommend with most of these videos. Pause the video here and write this down for yourself, because this is the process that we are going to be using and what I will be referencing as we go through some examples with this. So what we want to do pretty much breaks down into four main parts. We want to input the data into our graphing calculator. We want to view the data in our graphing calculator. That's going to give us an idea of what this looks like, either linear, quadratic, or exponential in nature. We are then going to calculate the actual regression that we need to do, and this is where for the Math 72 students, all you're going to be doing is a linear regression. For the Math 97 students, you could be doing a linear regression, you could be doing a quadratic regression, or you could be doing an exponential regression. This will all depend on what you see from viewing the data. After we've done that regression, we actually write out our equation. Again, for the purposes of what we are going to go through, we are going to disregard what r and r squared mean at this time. That's something that's going to be covered in a more advanced class, one that is geared more specifically towards statistics. This is meant to be very, very, very introductory in nature with all of this and getting an idea of what regressions are and what they could look like. Now I do want to note as well, as I'm scrolling down here with some of these. Oh, there's a spoiler for our answers there. Pretend we didn't see that. I'll go ahead and scroll us up. There we go. So some of these keystrokes are going to be slightly different based on the calculator that you are going to be using or in the software version that it has on it. I'm going to be using a program on my computer that emulates a TI-84, I believe it's a Plus CE calculator. So there might be some slight variations in this third chunk of steps, but by and large these are going to be very, very similar to what you will be using on your graphing calculators. Now once we have the answer and we have our best fit equation, we could calculate the x and y intercepts, the slopes, we could interpret values or what slopes mean, and we could find other values based on the new best fit equation that we have. I recommend that we use a calculator for this number crunching because the decimals absolutely will get gross. They get terrible, very painful with a lot of these. So once you have that equation made for yourself, there's any number of things you could do with it. And to try and keep this video going for less than 3, 4, 5 hours long, we are not going to touch on what we could do with those videos or with those best fit equations. Those are things that we've covered in previous videos and we just use a calculator for because of the decimals. Now the last note that I want to make before we dive into and actually look at some equations and some data and some things like that. Okay, pretend you aren't seeing the equations down here. I do want to make the note that regressions by their nature are not exact, but give us a really good estimate as to what sort of an equation is going to come out of the data. So when you are looking at your best fit or regression equation and your equation seems slightly off or maybe significantly off from the rest of the data, this is exactly as intended. This is normal. This is expected. We are used to seeing this. There's nothing wrong with it. The only part where things could go wrong in this process is at the very, very beginning when we're inputting data. So we have our overview of everything written out here. I want to go into these in a little bit more detail because it's kind of some warnings that I want to give you as you are going through this process and doing these regressions for yourself. The input data step, this first thing that we're doing, this is the most important step in this entire process. Every single point and every single number, every single decimal sign, every single negative sign that you do or do not enter correctly will absolutely destroy everything else that we do later on in our process. It is from this data that you're going to be viewing what this scatter plot looks like. So if the data is wrong, you're going to be looking at an incorrect scatter plot. Furthermore, if you're looking at an incorrect scatter plot, you will then be performing an incorrect regression potentially. And even if you're kind of sort of close with, yeah, it still looks, maybe it's linear in nature, but you're working with some data that you entered incorrectly, yeah, it still looks linear in nature. Okay, I do a linear regression and, I do get an equation. We enter that into an answer key or we check the answer somewhere in the book. We say, well, my answer's close, but also it's still off from what the answer key is. All of that comes back to incorrect data entry at the very beginning. So this is the step that will make or break every single thing that we do in the rest of this process. And the calculator isn't going to tell you that your information is wrong, so you need to make darn sure that what you're entering in is exactly what it should be into your calculator. Now with that said and our warnings here, I'm going to go through and show this process actually using a calculator. Again, pause the video and write all this down for yourself if you need to, but let's go ahead and take a look at our examples and then dive into the actual problems themselves. So our first example, we got 3 sets of data here. And these are the 3 that I'm going to be using. Again, I'd recommend pausing the video and writing these down for yourself so you know here's the first set of data, second and third sets accordingly. We're going to create a best fit line for the sets of data, and we're going to round our final answers when we do those regressions to 3 decimal places. So I'm going to try and have these displayed somewhere on the screen while we are going through the process, but again, have it written down for yourself so you don't necessarily need to be hoping that I have it up there, but we've got it for ourselves as well. So let's go ahead and dive into this and take a look at example 1. Alright, so let's go ahead and figure out how we can find the best fit equation for our first set of data. So what we are doing is we are going to, from the main screen of our graphing calculator, we're going to click on Stat. We're going to make sure we're in the edit option, the first edit option, edit ... And that's going to bring a whole bunch of lists up here. Make sure that list 1, list 2, list 3, list 4, list 5, and so on are completely cleared out. If there's anything entered into there, what you will do is use the directional key. You're going to go up to the list. You're going to click clear, and then you're going to click enter, and that will clear all of that out. We are going to enter the input data into list 1, and input data is generally X. And then we're going to enter the output data, which is generally Y, into list 2. Now reference your set of data and make sure that you are entering in every single number, decimal point, and negative sign exactly as it is listed in the order that it is listed. We're going to go ahead and do that now. So now we have all of our input values right in here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, those are looking good. I'm then going to go over to the output values and enter the exact same corresponding output values that go with the input values. And here we have all of our output values entered in. A big warning if you are entering in negatives here, do not hit this subtraction sign on the side. That tells the calculator subtract something from something else. We are entering in a negative number and we instead want to hit this negative button right here at the very bottom. This is our negative sign. We're not using the subtraction sign, we're using the negative sign. The reason we have to do that is because the calculator is dumb and it doesn't know the difference between just a negative sign and a subtraction sign. So we need to be extra clear with it for that. Now that we have all of our data entered in, we want to actually view this data and see what this looks like. So we're going to go up and hit second mode, which is the universal go home button sequence on the calculator. We then want to come up to y equals in the top left corner. We want to check to make sure if there's any equations written in here because these are going to distract us from the data that we want to look at. If we do have something entered in, which I do, we're going to go ahead and use the up and down arrows to maneuver to those respective equations, and we're going to clear those out. The next thing that we are going to do is come up to the top where we see plot 1, plot 2, and plot 3. We want to make sure that plot 1 is enabled, meaning it has this little black background behind it. And that tells me that this thing is going to plot scatter plot 1, which it designates as the first two lists that we just entered in. So now we can go through and then we can actually view what this graph looks like. So I can click on the graph option here. And we're noticing, oh, well, wait a minute, this isn't really showing me anything that I want. The window looks kind of weird and all of that. From here, we have a couple options on what we can do. We can come up to zoom in the middle, and we can always go to zoom option 6, which is zoom standard. That resets the window to its standard viewing area. And we're seeing, okay, great, I'm seeing a couple of my data points, but I'm not seeing everything. We can go a step further with this, and we can then go back up to zoom. We can scroll down to option 9 here, zoom stat, and that says to make this zoom adjusted with the statistics that we are working with. We can either hit the number 9 or we hit enter. I would be careful on hitting 9 only because different calculators might have zoom stat as 0 or 8 or something right around there. We'll go down to zoom stat, and there we go. Now we can see all of our data points. This thing, as we're looking at it, does it look linear in nature? Does it look parabolic in nature? Or does it look exponential in nature? For this one, this looks pretty linear in nature. Maybe it could be a very gradual exponential, but for the purposes of my class and what we are going to be going through, I'm not going to be that nitpicky about it. This looks linear. Let's commit to this being a linear equation because that's what it is here. So great, we make a note of this somewhere nearby. We have a linear set of data, so we are going to do a linear regression. Awesome. Let's go ahead and go back to the home screen, second quit, and now we are going to tell the calculator to do a linear regression for us. So what we're going to be clicking on is the Stat button. We're going to use the left and right arrows to go over to Calc, at the very top. And then we're going to scroll on down to option 4, LinReg, where we have this AX plus B listed in right here. Now some people pretty regularly ask, why can't I use the other LinReg equation down here? And you absolutely can. It will give you the same answer, but notice how the form and the way it's written is reversed. The variable is at the front, the variable term is at the front here versus the variable term at the end here. So we're just going to use LinReg, the first option, just because it's the quicker and more available one. Now this is where we're going to get into some differences in what our graphing calculators are displaying. Some people will display something similar to this. The X list, list 1. The Y list is list 2. This is exactly what we want. We can scroll on down here to calculate and we can hit enter. Some people might not see the screen. You'll just see LinReg show up on the main screen. You will just hit enter. We'll hit enter here and we should be getting to a screen like this. So fantastic. We have our equation y equals ax plus b. This is telling us that a is negative 3.105952. So see where we get this really gross, terrible decimal showing up. We don't like that. So we're going to round to 3 decimal places, which means that this a is going to be replaced with negative 3.106. I'm rounding to 3 decimal places. I look 1 beyond and would round this up to a 6. My b value would therefore be 25.214. And there I would have my overall linear equation of y equals negative 3.106x plus 25.214. And that would be my final answer for this problem. Let's go ahead and see how we enter in and solve our second set of data. We're going to follow the exact same steps and see how we get through this. Hopefully a little bit faster than our first example because we're doing a lot of the same thing. So we're going to be going over to Stat and entering in our data. Going under Edit, the first edit option. I've got a bunch of stuff in here, so I want to come up to the top of these lists, L1 and L2, and I'm going to hit Clear and then Enter. And then for the other list here, I'm hitting Clear and then Enter. And then I'm entering in my X values in the first column, Y values in the second column. And now I have all of my data entered in. I can go ahead and take a look at what this thing looks like graphically. I'm going to second quit, coming up to y equals just to make sure, yep, plot 1 is still on, and I don't have anything else in here. Excellent. Let's take a look at this graph. And we're seeing a couple data points. It is still set to the previous zoom settings that we had previously, so we can come back up to zoom. And we're going to scroll down and hit zoom stat. Have this thing auto adjust the window, the statistics we're looking at. There we go. So this thing looks, does it look linear? Does it look quadratic in nature, the U-shaped or the N-shaped? Or does it look exponential in nature, like it's starting off smooth and then it gets steeper and steeper and steeper and steeper? And again, we have a linear regression showing up here, a little bit of a bump in the middle. It's kind of going, then it dips down a bit, kind of comes back up, but it looks mostly linear in nature. So we're going to go ahead and do a linear regression for this problem. Going to go second quit. And we're going to go to Stat again. We're going to scroll over to Calc at the top, using left and right. And we're going to go down to option 4, LinReg again. Going to click on Enter. X list is list 1, Y list is list 2. Fantastic, that's already set. I can go ahead and scroll down to Calculate and hit Enter. And here I have my information regarding my brand new equation. So if I was rounding this to 3 decimal places, my final equation would end up being y equals 1.215x plus, actually it would be minus 2.591. And there we would have our final linear regression for our second set of data. We are now on our third example, and we are going to do the same thing that we did previously. We're going to be going up and entering in our set of data. We're going to be clicking on Stat. We're going over to the Edit tab at the top and the first edit option listed below. We're again going to clear out List 1 and List 2. We use the up and down, left and right arrows to maneuver to L2. We're going to clear that out and hit Enter. We're going to go to List 1, clear that out and hit Enter. We're going to enter in all of our input values in List 1, all of our output values in List 2. And once again, be careful. We did have a negative number showing up here. Make sure you are pressing the negative button at the very bottom of the calculator, not the subtraction sign on the right side. Great, we have everything entered in. Let's take a look at what this data looks like. Coming up to y equals, just double checking, plot 1 is on. This is all cleared out. Excellent. Let's take a look at our graph. We're seeing, okay, it doesn't look too bad there. Let's see if we might be able to adjust it a little bit and see if this gives us a slightly different view on this set of data. Clicking on Zoom, I'm selecting option 9, or zooming down to, or scrolling down to Zoom Stat. And let's see, okay, that's a little bit better. Now we're trying to determine, does this look linear in nature? It's like a straight line going up from left to right, going down from left to right. Does it look quadratic in nature, like an upside down parabola or an N or something like that? Or does this look exponential in nature, like it's kind of decreasing, then it gets more and more and more over time? And this is going to be quadratic in nature, so we're going to do a quadratic regression. So fantastic, we've got this nice and cleared for ourselves. So let's go ahead and do that quadratic regression here. We're going to go back to the home screen, second mode. We're going to come over here to Stat. We're going to go to the Calc option at the top middle. And then we're going to scroll down to option 5 here, which is QuadReg, a quadratic regression. Now before I hit this button, I do want to note, if we were going to do an exponential regression, we would be scrolling further down. And it's a little bit different depending on your calculator, but it should be written in as EXPREG for exponential regression. So I just want to note that this option is here, and it is something that you might be using with your problems, and just where that is in the calculation option. But for this problem, we're doing a quadratic regression. I'm going to go back up to QuadReg here. And now that I'm at the screen where it's asking list 1 for the X list, list 2 for the Y list, fantastic. I can go ahead and scroll down and hit calculate. And fantastic. Now I'm given a quadratic equation in standard form, this ax squared plus bx plus c, and I'm given what my a, b, and c values are. So, rounding this thing to 3 decimal places for a, b, and c, I would get a final answer of negative 0.276 x squared plus 4.528x minus 7.665 as my final answer here. A couple things I want to go through really quickly just so we can get the calculator back in its original state if we need to do graphing or anything else like that. We're just basically resetting, air quote, resetting our calculator here. So I'm going to come over here to Stat. And I'm going to just go ahead and go into my lists. And I'm going to clear these out so I have no data in here. And that's cleared out for the next time I need to come in and enter in sets of data for a new problem. I'm also going to come up here to y equals, and I'm going to make sure that plot 1, plot 2, and plot 3 do not have any kind of a shaded background behind them. So I'm coming up, and I'm hitting enter on this plot 1 because we were using that one, and it should be cleared out there. The last thing that we are going to do is we are going to reset our graph window back to its original standard spacing and window size that it has. We're going to go to zoom in the top middle, and zoom standard, that is option 6. We can go down to zoom standard, and we should see, hey, we've got a nice clean looking original graph set up here for ourselves. Now anytime we come back and enter in something that we want to graph up here in y equals, or the next time we're doing a scatter plot, we can just go into graph and we have our nice original graph window ready to go for us. So just some reset things that we have there. I would highly recommend remembering zoom option 6 or zoom standard to always be your graphing reset window button sequence. As a recap of what we covered here in the video, we were working with curve fitting and regressions. We had our definition of a scatter plot and how we create one, and we had our 3 kinds of trends and patterns that the information could be giving us. Again, if you're in my Math 72 class, you will only be working with doing linear regressions. If you are in my Math 97 class, you will be working with linear, quadratic, or exponential regressions. All 3 are available and fair game in the Math 97 material. We then had our overall process. So a lot of writing that was written out here. But again, at the end of the day, we are correctly inputting the data into our calculator. This is by far the most important step in the entire process. We are then viewing the data, and then we are then actually having the calculator calculate the regression of that data and writing that out in our final answer form. Again, making sure that our keystrokes that might be a little bit different from the ones written out here if you are using a slightly different version of a graphing calculator. Final reminder, again, remember that regressions by their nature are not exact, but give an estimated equation based on the data that is given to them. So these are never intentioned and never intended and never should be considered perfect. It's just as close of an estimate as we could possibly get. And then we had our 3 examples. Hopefully we can get all 3 of the sets of data in here if you wanted to give those another shot for yourself or give those a try. And otherwise, that will do it for our curve fitting and regression material.